Hello everyone, welcome back again to this part of the session of self-purification process. Mainly in the self-purification process, it is governed by the different factors. One is through the dilution technique, second one is related to the oxidation. The physical forces that tends to act upon, as well as even the chemical process that takes place. Physical forces normally acting upon is mainly due to the flow conditions, maybe the discharge, as well as the hydraulic flow conditions. In addition to that, exposure to the sunlight, which increases or the changes in the temperature takes place. Meanwhile, even the case of the wastewater that is discharged into the river bodies, what happens? It tends to have certain transformation. Mainly it is transported through the advection. The dispersion process takes place, since I have mentioned in the previous part of the class. In today's part of the class, let me solve the problems related to the dilution. What about the oxidation, reduction phenomena, sedimentation actions that takes place? I will explain it in depth through the means of oxygen sag curve. Okay, let us solve particular problems related to the dilution ratios, as well as how does the completely mixed systems takes place, the reduction in the concentration of the conservative substances of the matter. Let us get to know. Take down the problem related to the dilution factors. The wastewater of a town is to be discharged. The wastewater of a town is to be discharged into a river, full stop. The quantity of wastewater produced per day, the quantity of wastewater produced per day is 9 million liters, 9 million liters, 9 million liters, comma, and its BOD is 250 mg per liter, and its BOD is 250 mg per liter, full stop. If the discharge in the river is 225 liter per second, 225 liter per second, and its BOD is 8 mg per liter, and its BOD is 8 mg per liter, comma, find the BOD of the resulting mixture, find the BOD of the resulting mixture, full stop. The next line, what should be the river discharge? What should be the river discharge if it is desired to reduce, if it is desired to reduce the BOD of the resulting mixture to 25 milligram per liter, 25 mg per liter, 25 mg per liter. Okay, now let us solve the numerical problems related to the dilution. Numerical problem. First problem, what is the given data? Let us get to know about it. The wastewater discharges. What is the amount of the wastewater that is discharged into the river? Please do have a flow diagram while analyzing the question. There is a discharge of the wastewater. We have a QE. The concentration we call it as CE. There is a discharge of the river QU, and the concentration is CU. This wastewater is discharged to the river. The quantity of the wastewater produced per day is 9 million liters. quantity is 9 million liters, that is 9 mld, and its BOD is 250 mg per liter. BOD is nothing but instead of CE, you can take it as YE is equal to 250 mg per liter. 250 mg per liter. If the discharge in the river is 225 liter per second, if discharge in the river, how much it is given? 225 liter per second. 225 liter per second, and its BOD is 8 mg per liter. I'll take it as YU or CU, it is how much? 8 mg per liter. Don't confuse it with ultimate BOD, it is the upstream or a river you can take it. Okay. Find the BOD of the resulting mixture, they have asked. What is the BOD? That is YE of mix. Okay, YE mix is how much when they are discharge combination, and you can also determine what is the Q mix also. Okay, this is how you need to analyze the problem in the case of the river or streams. What is the formula given? Whenever you need to determine the concentration, either CE, YE or Q into S or anything, you can take it. In general, the formula given, dilution formula, S is equal to, that is QU or QR, SR plus QE, SE divided by QR plus QE. This is the formula, we have it. You can also denote it as Q. Similarly, the upstream part of the river where QR, it is 225 liter per second, YR is 8 mg per liter. First part of the problem you need to determine. First one is to determine BOD mix in the river. In the river. Same formula. So I need to determine what is the Y mix. Y mix is given as QR, YR and QE, YE divided by QR plus QE. This is equal to QR into YR, that is the concentration mass loading rate, 225 liter per second. Observe it here carefully. But what is given here? 9 mld. When 9 mld is given, please do convert in terms of an liter per second. So 9 into 10 to the power of 6 liters per day. When QE is 9 into 10 to the power of 6 liters per day, convert in terms of a liter per second. It has to match here. Thereby, you need to divide it by 24 by 60 minutes and 60 seconds. Let us calculate it. You have it as 104.17 liter per second. 104.17 liter per second. Now, what is the YR? It is expressed in terms of an mg per liter. Observe it here. Mg per liter is also important. YR is 8 mg per liter. Plus QE. What is the effluent? Now it is given as 104.17 liter per second into what is YE is equal to. Effluent is 250 mg per liter divided by, there is an addition of the flow due to the effluent containing the BOD concentration. Therefore, here you need to add it 225 liter per second plus 104.17 liter per second. That gives you nothing but Q. Okay, Q. What is at the downstream? Let us get to calculate what is the BOD mix. You can get it. BOD mix is given as 225 into 8 plus 104.17 into 250 divided by the sum of the discharge 225 plus 104.17. How much it is? 84.98. 84.98. Y mix is 84.98 mg per liter. That is BOD mix. As we have determined what is YE or BOD mix and Q mix. Q mix is sum of the 225 plus 104.17. You can able to determine it, that also. So first set of the question is completed for answering that. What they have asked in the second set of the question, what should be the river discharge? They are asking QR if it is desired to reduce the BOD of the resulting mixture to 25 mg per liter. 25 mg per liter instead of 84 point something, the resulting thing, what should be the river discharge if at all the concentration of the substances, that is a resulting mixture, has to be reduced from 84.98 to how much it is? 25 mg per liter they are asking. Second question, if Y mix is 25 mg per liter, compute QR. Compute QR. Now let us take it this side. Again apply the same formula. Here Y mix is equal to what is that? QR into YR plus QE into YE divided by QR plus QE. Now you need to compute QR if the Y mix is 25 mg per liter. So 25 is equal to QR, I don't know what is the discharge, but YR I know, same concentration into 8 plus what is QE given as 104.17 liter per second into what is the YE value? YE is 250 mg per liter. 250 mg per liter plus QR, I don't know. QE is given as 104.17. 104.17. Now, which implies that 25 into QR plus 104.17 is equal to 8 times of QR plus 104.17 into 250. How much you are going to get it? 104.17 into 250. 26042.5. Two 6042.5. Now open the bracket, 25 times of QR plus 104.17 into 25. So 104.17 into 25 gives you 2604.25 is equal to 8 times of QR plus 2604.2.5. Okay. Now bring the like times to one side, LHS. So 25 QR minus 8 QR is equal to 2604.2.5 minus 2604.25. 25 minus 8, how much? It is 17 times of QR is equal to, you need to deduct the portion. So 2604.2.5 minus 2604.25. How much it is getting? It is equal to 23438.25. So this is the rate of the discharge. Now QR is equal to 23438.25 divided by 17. That will be in terms of in liters per second. Divided by 17. Answer is 1378.72. 1378.72 liters per second. So if at all, if the mixing concentration instead of 84, it has to be 25 mg per liter, then the rate of the discharge which is affecting has to be increased. How much time it is? So 1378, here you have 225. That much of the times you need to raise, or it should be the discharge, then only you can able to get it. Okay, getting the point clear? The required river discharges, therefore the required river discharge is equal to 1378.72 liters per second. Hope so you people are getting clear for this. This is the normal formula, we need to use it. By this you can able to determine whatever the given conditions or the constraints. Getting the point clear for this? Okay, let us take on for the next problem. Next problem is much more interesting. You have to determine the combination of the three parameters. Down. The wastewater effluent, a wastewater effluent of 800 liter per second, a wastewater effluent of 800 liter per second with a BOD is equal to 70 mg per liter, with a BOD is equal to 70 mg per liter, comma, DO content is equal to 3.0 mg per liter, DO content is equal to 3.0 mg per liter, and temperature is equal to 25 degrees centigrade. Enters a river where the flow is 30 meter cube per second, where the flow is 30 meter cube per second, and BOD is equal to 3 mg per liter, and BOD is equal to 3 mg per liter, comma, DO content is equal to 8.8 mg per liter, and temperature is equal to 18 degree Celsius. Full stop. Determine the following mixture of the wastewater and the river water, determine the following for the mixture of wastewater and river water. First one, combined discharge, second one BOD, third one DO, and fourth one temperature. Let us get to know what is the background concentration. Make a diagrammatic representation, it will be easy for you. Given data, by reading the problem you need to analyze what are the contents. Again there is a flow of the wastewater having the background concentration BOD, DO, I could take it as C, and temperature is equal to. Similarly for the river discharge, BOD concentration, DO concentration, as well as the temperature also. How much they are asking? The wastewater effluent of 800 liter per second, 800 liter per second. Okay. Next, with BOD given as 70 mg per liter, Y is equal to 70 mg per liter, and C is given. What is that? The DO is 3 mg per liter. DO is 3.0 mg per liter. And temperature is equal to 25 degrees Celsius. 25 degrees Celsius. Enters a river. This is the wastewater effluent discharge. This is the river. Mixing process. Enters the river. The flow is 30 meter cube per second. Flow is 30 meter cube per second. Observe it clearly. This is 30 meter cube per second, whereas this is in terms of an liter per second. You need to convert in terms of an meter cube per second. Next, YR is given. What is the YR value? The BOD is 3 mg per liter. 3 mg per liter. What is the DO concentration is? 8.8 mg per liter. 8.8 mg per liter. And the temperature is 18 degrees. 18 degrees Celsius. What they have asked? First one they have asked determine combined discharge. Combined discharge. Obviously, you need to determine what is the Q. That is nothing but the downstream concentration. Combined discharge. First one is BOD. Combined discharge BOD. Second, they are asking about the DO. And third one, or let me take it as second one, third one, and fourth is related to the temperature. What we know the formula? Here given to determine the first one, to determine combined discharge. Combined discharge. To determine combined discharge, how much? We have the formula that is QS is equal to QR SR plus QE SE. Okay. To determine the combined discharge, I need to know what is the concentration. Then only it is easy for me. Which implies that Q is equal to nothing but the sum of the river discharge plus the effluent discharge. I need to find out what is the combined discharge. Q combined. Now let me check how the units are given. QE is 800 liter per second. Now QE is equal to 800 liter per second. has to be converted as 800 divided by 1000. It has to be converted in terms of an meter cube per second. Therefore, 1 liter is equal to, 1 meter cube is equal to 1000 liters. Thereby, 800 by 1000 gives you 0.8 meter cube per second. 0.8 meter cube per second. Now, I have 30 meter cube per second and this is 0.8 meter cube per second. Now, find out what is the Q combined. So, combined discharge is Q combined is equal to QR. What is the QR given? QR is 30 meter cube per second and QE I have got here itself only 30 meter cube per second plus 0.8 meter cube per second. Resulting answer should also be in terms of in meter cube per second only. 30 plus 0.8, it is 30.8 meter cube per second. That is the combined discharge. Combined discharge. Second one, what they have asked, determine the BOD, that is the combined. First one is discharge. Determine the following mixture of the sewage water, the wastewater, that is combined. So, BOD mix, DO mix and T mix. Temperature mix. To determine the combined BOD, there is a BOD mix. BOD mixture, same thing, apply the same formula, you are going to get it. So, QS is equal to QRSR plus the following QESC. Now, from this, I have what instead of S, I have taken as S is replaced by YE. Okay, the effluent or YR, the BOD, where Y is BOD here. I need to determine the S or the BOD mix, so Y mix. Y mix is equal to QRSR plus QESE divided by QR plus QE. Y mix is equal to, what is the discharge? Here QRYR, QEYE and QR divided by QR plus QE. Y mix by Y mix is equal to, what is the QR? QR is 30 meter cube per second. So, 30 into, what is the YR concentration? 3 mg per liter. Here it is given in terms of an mg per liter. Either you need to convert in terms of a meter cube per second or in terms of an mg per liter. If I have converted always in terms of a meter cube per second, already I have stated that 1 mg per liter is nothing but equal to 1 gram per meter cube. 1 gram per meter cube. Apply the same concept here. So, 30 meter cube per second into YR is 3 mg per liter, that is 3 gram per meter cube, 3 gram per meter cube, plus what is the next set of the concentration? We have QE is 800 liters, so it is 0.8 meter cube per second, 0.8 meter cube per second into, what is the YE? 70 mg per liter, that is 70 gram per meter cube, divided by 30 plus 0.8. We have the combined discharge here. So, combined is equal to 30.8 meter cube per second. Now, meter cube per second and gram per meter cube, you have only gram per second. And again, the Y mix will yield a result of gram per meter cube only. That is nothing but in terms of an mg per liter only. So, 30 into 3, this is 30 into 3, 90, and 0.8 into 7, 7 8 is 56, 33 is a 90. 90 plus 0.8 into 7, 7 8 is 56, it is 5.6, divided, that is 95.6, 38.8, that is 95.6 divided by 30.8. you have Y mix is equal to plus, we have 56, 146 divided by 30.8. How much? 4.74. 4.74, either in terms of a gram per meter cube you can keep it, or in terms of an mg per liter. Keep it as a ready reckoner part. Next, second one completed. DO mix they have asked. What is the DO mix? Second one, to determine DO mix. DO mix. These problems are making easier for the next step or the procedure when you solve for the Streeter-Feb's equation to determine what is the DO deficit and all. To determine DO mix is given as C mix. C mix, that is equal to QR CR, CR here, CR, and this is CE. QR CR plus QE CE divided by QR plus QE. C mix you have got to replace it by this formula. Replace S instead of YE for here. Here you can take it as CE. Now what happens? QR, what is the discharge? Given as 30 into, what is the concentration of the DO here? It is 8.8 mg per liter, 8.8 mg per liter. Again it is converting in terms of a gram per meter cube, into plus 0.8 is the discharge of the effluent, 0.8 meter cube per second, 3.0 mg per liter. What is the DO is? 3.0 mg per liter. That is divided by 30.8. 2.4 plus 30 into 8.8. So here we will get it as 30.8, 30 into 8.8 plus 0.8 into 30, 264 divided by 30.8. The resulting DO mix is 8.57 mg per liter. The resulting concentration is 8.57 mg per liter, or it is also expressed in terms of grams per meter cube. Remaining part is what? To determine what is the T mix. Replace CR by T, or replace S by the T. Whatever the formula that we are applying here, you need to replace it. Now third one is to determine the temperature mix. I am rubbing this part. T mix, temperature mix. T mix is equal to QR into TR plus QE into TE divided by QR plus QE. QR plus QE. We call it as a T mix. Same formula where you have applied 30 into 30 meter cube per second into, what is the temperature? 18 degrees. Here 18 degree it is given 30 into 18. Temperature is slightly low here, temperature is slightly high here. QE 0.8 into 25 degrees plus 0.8 into 25 degrees. So here the temperature concentration you can able to determine, because only the discharge temperature in terms of in degree Celsius you get it. The discharge terms get cancelled here. Divided by 30.8. How much? Calculated and expressed in terms of in degree Celsius. 30 into 18, 30 into 18 plus 0.8 into 2.5, 0.8 into 2.5 gives you 542 divided by totally 30.8. The average resulting temperature is, you get it as 18.18 degree Celsius. This is how you need to determine the temperature. This is how you need to determine the temperature mix conditions. In any of the question papers, or they go for asking any discharge concentration, you need to determine by the application of the dilution technique or the method of estimation of the wastewater discharge. Okay, getting the points clear for this. Now, take down the next problem. It is quite different. The treated domestic wastewater of a town, is to be discharged in a stream, full stop. Determine the maximum permissible effluent BOD. Determine the maximum permissible effluent BOD and the percentage purification required in the treatment plant with the following particulars. What are those? Let us get to know the another. Population of town is 40,000, given data. This is the third problem. Population of a town is equal to 40,000. Minimum flow of stream is QS here. It is QS, minimum flow of stream is how much? 15 in terms of 0.15 meter cube per second. 0.15 meter cube per second. Next, BOD of stream is, you can take it as Y5. BOD of stream is YS is equal to, how much concentration is? 2 mg per liter. 2 mg per liter. Dry weather flow of wastewater. Wastewater is equal to how much? 150 liters per capita per day, that is 150 LPCD. BOD contribution per capita is equal to how much? It is 0.075 kg per day. 0.075 kg per day. Maximum BOD of stream on downstream. Maximum BOD of stream on downstream is equal to how much? Given as 5 mg per liter. 5 mg per liter. Now let us analyze same set of the flow condition. It is given what it is. Stream population is given, BOD contribution I need to estimate it. What is the discharge as well as the BOD I need to determine, then only I can get to know what is the purification given. Here contribution per capita is given as 0.075 kg per day. Now let me compute what is the dry weather flow of sewage. I need to determine what is the QE. Q of dWF is equal to question mark. Now solution I need to provide it. First one, determine the dry weather flow. Dry weather flow, because whatever the river you have and its surrounding BOD concentration or a stream it is given, no? Stream and its BOD concentration. You have an effluent disposal having QE as well as the YE also. How much? That you need to determine it. But they have not asked in this manner, they have asked in separate manner. I need to know the maximum BOD of the downstream is 5 mg per liter, that is Y mix. I know how much it is, 5 mg per liter. This is the upstream condition, this is the downstream condition. Please do analyze the problem properly and then you can move ahead. Otherwise, it is not easy to think about this solving of the problem. Q dry weather flow is nothing but, the formula is dry weather flow of wastewater into population. It is refers in terms of liters per capita per day. Population is, this is 150 into 40,000. Think it is liters per day. Liters per day. Liters per day. Now I need to convert the liters per day in terms of either meter cube per second, or it is better to convert liters per day in terms of meter cube per second. Thereby 150 into 40,000 divided by 1000, converting the liters in terms of meter cube, divided by 24 into 60 minutes and 60 seconds. How much you get it? It is expressed in terms of meter cube per second. Thereby computing this, you get it as 0.069 meter cube per second. Now, given Qs minimum is equal to minimum flow in the stream is given as, Qs is given as 0.15 meter cube per second. Now we have determined what? Qs is already given as 0.15 meter cube per second, and they have also asked Qs, this flow of the stream is asked. What about here? Effluent discharge is 0.069 meter cube per second. I need to determine the BOD concentration. I need to determine the BOD concentration. How to determine the BOD concentration? Observe the question carefully here. Determine the maximum permissible effluent BOD and the percentage of purification required. Maximum permissible effluent BOD. Maximum permissible effluent BOD. That is, YE is question mark because YS is given as 2 mg per liter. Solve the formula. We know that the dilution factor formula, that is, I have the maximum BOD, the downstream is given as, so Y mix is equal to QE Y, sorry, you can take it as QS into YS plus QE into YE divided by QS plus QE. This is QS is what? How much it is? 0.15 into YS. YS is in terms of 2 mg per liter. 2 mg per liter into 2. Don't worry about the conversion factors. Anyhow, it is gram per meter cube only, you are getting it. The gram per meter cube is nothing but again it is 1 mg per liter. Now into 2 and QE. I know QE is equal to 0.069 into YE. I don't know what is the effluent contribution of the BOD, but have contribution per capita. What is the required maximum permissible limit is only 5 mg per liter. So this is the standards they have set. If you need to have the proper standards to comply with 5 mg per liter, what should be the discharge of the effluent containing the BOD concentration that they are specifying, or how much percentage of purification is required. YE divided by QS is 0.15, again QE is 0.069. Y mix is given as how much? They are at the downstream, it is 5 mg per liter, that is the maximum permissible limit concentration. This is how you need to analyze the problem. Simply you cannot go like by hearting all these things. Now I need to determine YE. So 5 into how much you are going to get it? 0.15 plus 0.069 is equal to 0.15 into 2 plus 0.069 times of YE. I'll make it as a YE itself only. 5 into 0.15 plus 0.069 minus 0.15 into 2 divided, so this is 0.069 times of the YE, which further implies that YE is equal to 5 into 0.15 plus 0.069 minus 0.15 into 2 divided by 0.069. Compute what is the YE in terms of an mg per liter. This is how you need to compute it. After computing it, you get the answer as 11.52 mg per liter. What they are asking is the maximum permissible BOD, maximum permissible BOD is 11.52 mg per liter in the effluent discharge. Effluent discharge. Second, they have asked what is the percentage of purification required. The next question, BOD and the percentage purification required in the treatment plant. Percentage purification, determine percentage purification required. Determine percentage purification required. Percentage purification required. Percentage purification required, I need to determine what is the concentration of the, if the maximum permissible limit is, if not, what was the concentration, that is the actual concentration I need to determine. Actual BOD of effluent I need to find out. First one is determine actual BOD of effluent, actual BOD of effluent, actual BOD of effluent, that is given by BOD in mg per liter is nothing but what is the per capita contribution, that is BOD contribution is 0.075 kg per day, and we have it as I need to get in terms of an effluent BOD in mg per liter, that is BOD contribution in per capita, BOD contribution in per capita divided by they are asking the concentration, so C is nothing but W divided by Q. Okay, the waste effluent discharge, that is per capita they are asking it, dry weather flow. Okay, dry weather flow is what? It is dry weather flow. Remember the formula, this is helpful. How much BOD contribution is given as 70.075 kg per day, and here it is in terms of an liters. What I require BOD in terms of an mg per liter. I need to convert the kg in terms of an mg. In mg, kg in terms of an mg. So multiply by 10 power 6, because 1000 milligrams makes 1 gram. Again 1000 grams makes 1 kilogram, thereby 0.075 into 10 raised to 6 divided by 150. This is in terms of an kg, mg you get it per day, and this is in terms of an liters per day. Per day and per day get cancelled here. 0.075 into 10 raised to 6 divided by 150. That is equal to 500 mg per liter. 500 mg per liter. Because 15 5 is 75. This is the actual. Q actual, that is the YE actual is 500 mg per liter. But Y mix changes. If it is desired, how much is the percentage of purification? You need to determine it. Okay, let me complete it here. Thereby compute percentage of purification. Percentage of purification. When you compute the percentage of purification is expressed as actual, that is Y actual, BOD of the actual, minus what is the permissible BOD, Y permissible, divided by actual, Y actual, whole thing if you need to multiply by 100. I don't have space here, that's why I am writing it here. That is Y actual is equal to 500, getting it, 500 minus permissible is how much, 11.52, maximum permissible 11.52 divided by 500 gives you into 100, okay, gives you in terms of in percentage 500 minus 11.52 divided by 500, it is around 97.7%. 97.7%. That means when you are discharging the concentration percentage of, for you getting the 11.52, instead you have it as 500. To bring down the 500 to 11.52, 97.7% of the purification, so the efficiency of the treatment has to be imparted in the wastewater treatment plant. Should be efficiency is equal to 97.7%. That they are asking it. Okay, these are the another set of the problems that we tend to solve it. Hope so you have understood the problem, how to calculate in this situations. Analysis becomes very much important in the wastewater effluent disposal. Here onwards, thinking as well as analyzing becomes very much important here. Okay, and to apply the concepts related to that, how it is and all, in a practical aspects through the line diagram. It is important. With this, I'll wind up the class. In the next stages, let us take up the oxygen curve demand and street effects equation related to the zones of the recovery. How does the equations help to resolve the crisis if the DO deficit it tends to happen? Still then, stay tuned for it. Let us continue in the next part of the class. Thank you, one and all.